Alright, let's look at an example. Now I repeated the equations here. Alright? So x bar and y bar, the location of centroid or center of gravity. Right? The same thing if this rigid body is made out of homogeneous material. Okay? And by the way, numerator of each equation is called the first moment. Right? In particular, this guy right here is called the first moment of the area A about the y-axis. Right? Y-axis, x tilde. Similarly, this guy right here is called the first moment of the area A about the x-axis. Okay? It's just terminology. Let's look at a simple example, and this is probably the simplest example I can give. Right? A rectangle. Now, from experience, you know exactly what centroid is. Okay? It's just in the middle. But let's prove it. Okay? Using these equations. Okay. Now, first thing you want to do before you start writing down equations is you should define the coordinate system. Right? Where do you want to put the origin? Right? Now, this is x and y, so obviously you want to define x and y axis somewhere. Okay? You can place it anywhere you like, anywhere. Okay? And your final answer, x bar and y bar, okay, will be unique to where you define your coordinate system. Okay? So let's say if I define my coordinate system this way. This is my x-axis. This is my y-axis, which means that the origin is right here, the 0, 0 point. Then my answer, x bar and y bar, will be relative to this origin right here. Okay. Now, if you define, let's say, the origin here, right, so x-axis and y-axis up here, so the answer, x bar and y bar, will be different, right, from this coordinate system, obviously. Right? So it will be, both numbers will be negative values. Right? So first, define your coordinates. Okay? Next, now this is a common shape, right? So I know the height and width. Let's say the width, we call it x1, okay? And the height is y1, right? So they're both constant. Okay? I don't want to put in numbers here because I want to keep it general. Okay? So with these two defined, well, again, from experience, you know where the center of gravity is, or centroid is, right? So the x bar should be 1/2 of x1, and y bar should be 1/2 of y1. Well, let's prove it. Now, these three equations right here involve integral with respect to area, dA. Okay? Now, dA has to be rewritten in terms of dx and dy, because now here's our coordinate system, right? So we have split this area into x and y axis, x and y components. Now, to perform this integration, really there are three ways to do this. The first method is that you can split this area into a tiny area like this, okay? And then just do the integration in each direction. So this dA right here becomes actually double integration. Let's say this guy, that's just for x bar. So it becomes x tilde. dA now becomes dx dy. Okay? So you do integration, the inner integration first over dx, so some everything in the x direction, and then you do it in the y direction. And that's perfectly okay. The second way to do this you define a strip of element, okay? An elemental strip, okay, like this. And then you sweep it. You sweep it up and down, okay? Let's say from this location all the way up, okay? As long as you cover the entire area, then you're okay. So this can become, right? So x tilde, right? So now this width now is exactly x1, okay? And then the height of this element right here, right, where the centroid of this element is exactly y-axis. Okay. All right. So now this becomes x bar, and then dA, or the area of this little strip right here, right, would be this width, x1, times this little height of this elemental strip, and this little height is y. Right? So dA becomes x1 dy. Okay? So right? And then you can just keep simplifying further. Right? So this x1 right here, right, is a constant, right? You can just take it out, okay? And then this x tilde, right, which is the coordinate, the x coordinate, of the centroid of this elemental strip, which is down middle. Okay, so this is x tilde, and x tilde is 1/2 of x1, right? So 1/2 of the entire width, right? So you can just replace it in here. Okay. Now, the third way to do this, okay, which is what I'm going to do here, is let's do it here. Right? So the third way, right, is I'm going to define a vertical strip. Okay. And then sweep it from x equals 0 location all the way to x equals x1 location. Now this way I cover the entire area, and I'm okay. Okay. So my x bar equals, let me write down the entire equation. Okay. So now I need to replace this dA with something. dA, which is the elemental area of the strip right here, which is this width, which is dx, times height. Height of this strip is exactly y1. Okay. And x tilde, which is the centroid of this elemental strip, right? Again, tilde means element. Okay, this little strip is my element, and the centroid of this guy is right in the middle. Okay, so the x tilde is this distance right here, and since this doesn't measure from 0, x equals 0 location, to this location, so this is simply x. Okay, so my x tilde is my x coordinate, right? What about y tilde? This is my y tilde, y coordinate of the centroid of the element strip, equals Well, again, this is measured from 0 location all the way up, and it's exactly half of y1. So 1/2 y1. Now we're ready to replace this dA, right, x tilde dA, with something else. X tilde is x. dA is y1 dx. Okay? So area, right, equals y1 times this, right, this little dA. Okay? Divided by area of the whole thing, okay, which is x1 times y1. Keep going. y1 is a constant, so take it out. y1, what's left? X dx. Divided by x1, y1. Okay? Now this integral, okay, you integrate from the lower limit to higher limit, okay, of the x-axis, right? Because we are integrating with respect to x. And where do you integrate from? Well, from 0, right? Because you're trying to sweep this strip from 0 location all the way to x1 location. So 0 to x1. All right. So now look at this. Cancel out. Now this is very, very simple integration. Right? So 1/2 x squared 0 to x1 divided by x1 equals, replace it in here, so we have 1/2 x1 squared divided by x1. Look at that. That's my answer. 1/2 x1. There you have it. This is my x bar. And do exactly the same thing for y bar. Right? So A, so A equals blah blah blah. This exactly equals to 1/2 y1. That's it. This is the answer. So half of this, which is right here, and half of the y. This is my G.